So today we're going to, the first one I'm just going to show you how we could do this problem two different ways. Now, if you look at this, could you think of log base 4 of 32 as log base 4 of 16 times 2? Yeah? Alright, so that would break into log base 4 of 16 plus log base 4 of 2. Okay? What is log base 4 of 16? 2. And when I take the square root of 4, do I get 2? So what power means square root? The half. So this is 2 plus a half, which I could write as 2.5 or 5 halves, right? Or 2.5, doesn't matter. Okay, so this is solving a problem that we used to only do one way, a different way. Because this problem we used to write as log base 4 of 32 equals x. So 4 to the x equals 32. So 2 to the 2x equals 2 to the 5th. So 2x equals 5. And x is 5 halves. Are they the same? Yes, they are. So it's just a different way to using the properties to evaluate log base 4 of 32. Now, whichever way you like is the way you should do. Now, these are some weird looking ones, but they're actually really simple using our properties of logs. What can we do with this exponent on this next problem? We can bring it out in front. So this crazy looking thing becomes now 8 times log base 2 of 2. And what power do you raise 2 to get 2? The first. So it's just 8 times 1. This is 8. Does that make sense? All right, this is either easy or hard or we're tired. A little bit of both? Okay. Number 3. So log base 5 of 25 to the 9th. What can we do with the 9?
Put it over to the front.
It can come out in front. Is this easy to simplify? Yeah. What's the power? What? 2. 5 squared is 25. So this becomes 9 times 2, which is 18.
So when you're doing problems like these, you should look at like log 5 to the 25 almost as if like one number.
Yeah, it is. Because the answer to a logarithm is just the exponent. All right, now, I can't look at this and do anything with it. It is bizarre looking. There is a logarithm as the exponent. That just seems wrong. Because a logarithm is an exponent. So, whenever I get befuddled, which happens often, but whenever I get befuddled with logarithms, if I don't like the way it looks, I switch forms. So right now I have a base raised to an exponent. Well, that equals some answer in exponential form. A base raised to an exponent equals an answer. And if I switch forms, so this is exponential form, if I switch to logarithmic, it becomes log. What is the base in here? 5 of the answer equals the exponent. What is the only thing A can be? 2. So this craziness is just 2. All right, what do you think the answer to 5 is? X. But let's see why. So a base raised to this craziness equals an exponent. Equals an answer, excuse me. So we switch to log form. Log base b of a equals this exponent, which happens to be log base b of x. So what does a have to equal? X. Now, we do have to be careful, because what if I took number 4 and I stuck a little 3 right here? We can't just say the answer is 2, because this 3 has to boop back up, and so the answer is 8. Okay. Now, weird ones this way. So these are similar to what we've done, but different. So log base x plus 1 of 27 equals 3. All right, log base x plus 1 of 27 equals 3. All right, can anybody look at it and tell me the answer?
1.
All right, so when we can't look at it and immediately say the answer, we have to switch forms. So the base is x plus 1. It is 2. The exponent is 3. It equals 27. Do you see? You might just see that 3 cubed is 27. But if we took the cube root here, we get x plus 1 equals 3, so x is 2. I'm just wondering how anybody could ever get so bored in math that they would draw on a desk. Really, math is fabulous. All right, log base x of 6x minus 5 equals 2. When we switch forms, what do we get?
X squared
X squared
equals 6x minus
equals 6x minus 5. Right, roll. Now what?
factor.
It's a quadratic. What do you have to
Factor.
set it equal to 0. Move this over. Move this over. Now what do we do?
Factor.
We factor.
X plus 5x, or x
Minus 2.
5x minus 1.
X minus 5, x minus 1. You switch those two in your head, Carlos. All right, so my answers are 5 or 1. And they both work, because if I plug in 5 or 1, I get a positive base here. So that's good. All right. You try. Number 8. No confusion after that bugger. Okay. Carlos, do you need a new pencil? No, he's happy. He's happy. And he can twist it right. Both ends.
Yeah.
One end per problem. All right. So we switch forms. And we get n squared equals 2n plus 8. So we set it equal to 0. So we're going to move the 2n over. It becomes negative. We move the 8 over. It becomes negative.
4.
I like it. X minus 4. X plus 2, right? So my answers are, whoa, this isn't X, this is N. Crazy, I just switched variables right in the middle of the problem. So N equals 4 or negative 2. But stop! Is a logarithm defined for a negative base? No! So N only equals 4. What do we call it? What is negative 2 called? An answer that we find algebraically that is not a solution to the problem? Extraneous. Yes, extraneous solution. All right. So this one doesn't count. Okay. All right. Let's see what this. Oh. Okay. Just watch this. This is free of charge, and you will not be tested on this. But I do want you to see how we could use the properties of logarithms just in case. I have not seen this on a sample SAT or ACT, but they could throw it out there. So I wanted to expose you to it. This was day 10 that I decided to skip. That was our non-essential day, but I do want to show you one or two. Not going to be on your quiz though. Okay? So how could I rewrite 48 if I know log base 5 of 8 and log base 5 of 6? I can rewrite it as log base 5 of 8 times 6. Then what can you do with a product? You can rewrite it as addition. And so if log base 5 of 8, you're given the approximate value of 1.292, and log base 5 of 6 has an approximate value of 1.113, then we could just add those two together, and then we carry, and then so that makes a 4 and a 2.2405. Okay, how can we take the 8 and the 6 and create a 3/4? 6 over 8, yes. That's the same as 6 over 8. So, what does log base 5 of 6 over 8? Good. So we would do 1.113 minus 1.292. Got the idea? All right, let's jump down to this one. This gives us log base 7 of 3 and log base 7 of 10. How can we get 90 out of that? 3 squared times 10. 9 times 10. So 3 squared times 10. So this becomes 2 log base 7 of 3 plus log base 7 of 10. So we'd have 2 times 0.565 plus 1.183. All right, so once again, not on your quiz. Not on the quiz. But you, you know what, that's a good idea. I hadn't even considered that. I have not run your quizzes off, so that's a possibility. Okay. All right. So that's it for today's lesson.